Good morning, everyone. Welcome back to Chemistry 101. Today, we're diving into Chapter 4, Stoichiometry of Chemical Reactions. This chapter will explore the quantitative relationships between reactants and products in chemical reactions. We'll cover concepts such as the mole, molar mass, limiting reactants, percent yield, and solution stoichiometry. Mastering stoichiometry is crucial for understanding and predicting the outcomes of chemical reactions in high school, honors, and AP chemistry. Let's get started. The mole and molar mass. Definition of the mole. The mole is a fundamental unit in chemistry that represents a specific quantity of particles. 1 mole of any substance contains Avogadro's number of entities, which is 6.022 times 10 to the 23rd power of particles, atoms, molecules, ions, etc. The mole provides a bridge between the atomic and macroscopic worlds, allowing chemists to count particles by weighing them. Molar mass. Molar mass is the mass of 1 mole of a substance, expressed in grams per mole, g/mole. It is numerically equal to the atomic or molecular weight of a substance in atomic mass units, AMU. Molar mass is used to convert between the mass of a substance and the number of moles. Example, the molar mass of water H2O is approximately 18.02 grams per mole. This means 1 mole of water weighs 18.02 grams. Using the mole and molar mass in calculations. To convert between mass and moles, use the formula. Moles equals mass, G, divided by molar mass, G/mole. Example, to find the number of moles in 36.04 grams of water. Moles of H2O equals 36.04 G divided by 18.02 grams per mole equals 2.00 moles. Balancing chemical equations and stoichiometric calculations. Balancing chemical equations. Balancing chemical equations is essential for stoichiometry because it ensures that the law of conservation of mass is upheld. A balanced equation provides the mole ratios of reactants and products needed for stoichiometric calculations. Example, balancing the combustion of methane. CH4 plus 2O2 goes to CO2 plus 2H2O. Stoichiometric calculations. Stoichiometric calculations use the mole ratios from balanced equations to determine the amounts of reactants needed or products formed in a chemical reaction. 1. Identify the given and required information, determine what you know and what you need to find. 2. Convert units to moles, use molar mass to convert given quantities to moles. 3. Use mole ratios, apply the coefficients from the balanced equation to relate moles of known substances to moles of unknown substances. 4. Convert moles to desired units, convert moles back to grams or other units as needed. Example, if 5.00 grams of CH4 are burned, how many grams of CO2 are produced? Convert CH4 to moles. Moles of CH4 equals 5.00 G divided by 16.04 grams per mole equals 0.312 moles. Use the mole ratio from the balanced equation. Moles of CO2 equals 0.312 moles times the conversion factor 1 mole of carbon dioxide divided by 1 mole of methane equals 0.312 moles. Convert moles of CO2 to grams. Grams of CO2 equals 0.312 moles times 44.01 grams per mole equals 13.73 G. Limiting reactants. Concept of limiting reactants. In a chemical reaction, the limiting reactant is the reactant that is completely consumed first, limiting the amount of product that can be formed. The other reactants are present in excess. Steps to identify the limiting reactant. 1. Balance the chemical equation, ensure the reaction is balanced. 2. Calculate moles of each reactant, convert the mass of each reactant to moles. 3. Use stoichiometry to determine product formation, calculate how much product can be formed from each reactant. 4. Identify the limiting reactant, the reactant that produces the least amount of product is the limiting reactant. Example, consider the reaction between nitrogen and hydrogen to form ammonia. N2 plus 3H2 goes to 2NH3. Given 10.0 g of N2 and 10.0 g of H2, identify the limiting reactant. 1. Convert N2 and H2 to moles. Moles of N2 equals 10.0 g divided by 28.02 grams per mole equals 0.357 moles of N2. Moles of H2 equals 10.0 g divided by 2.02 grams per mole equals 4.95 moles of H2. 2. Calculate NH3 formation. Moles of NH3 from N2 equals 0.357 moles times 2 moles NH3 divided by 1 mole of N2 equals 0.714 moles. Moles of NH3 from H2 equals 4.95 moles times the conversion factor 2 moles NH3 divided 3 moles H2 equals 3.30 moles. Identify a limiting reactant. N2 produces less NH3, so it is the limiting reactant. Percent yield. Definition of percent yield. Percent yield measures the efficiency of a reaction by comparing the actual yield, amount of product obtained, to the theoretical yield, maximum amount of product predicted by stoichiometry. Formula for percent yield. Percent yield equals actual yield divided by theoretical yield times 100. Calculate percent yield. 1. Calculate theoretical yield. Use stoichiometry to determine the maximum amount of product possible. 2. Measure actual yield. Obtain the actual amount of product from the experiment. 3. Compute percent yield. Use the formula to calculate percent yield. Example: if the theoretical yield of NH3 is 17.0 g and the actual yield is 15.5 g. Percent yield equals 15.5 g divided by 17.0 g times 100% equals 91.2%. Solution stoichiometry. Concentration and molarity. Concentration measures the amount of solute dissolved in a given volume of solution. Molarity, big M, is the most common unit, defined as moles of solute per liter of solution. Solution stoichiometry calculations. Solution stoichiometry involves using molarity and volume to calculate the amounts of reactants or products in a chemical reaction involving solutions. Steps for solution stoichiometry. 1. Write the balanced equation, ensure the reaction is balanced. 2. Calculate moles of reactants or products, use molarity and volume to determine moles. 3. Use stoichiometry for calculations, apply mole ratios to find the desired quantity. 4. Convert to required units, convert moles to grams, liters, etc., as needed. Example: calculate the volume of 0.500 m of HCl required to react with 5.00 g of NaOH. 1. Write balanced equation, HCl, AQ, plus NaOH, AQ, goes to H2O, L, plus NaCl, AQ. 2. Calculate moles of NaOH. Moles of NaOH equals 5.00 g divided by 40.00 g / mole equals 0.125. 3. Use stoichiometry. Moles of HCl equals 0.125 moles times 1 mole HCl divided by 1 mole NaOH equals 0.125 moles. 4. Calculate volume of HCl. Volume of HCl equals 0.125 moles divided by 0.500 m equals 0.250 L or 250 milliliters. Real-world considerations and modern-day applications. Stoichiometry in industry. Stoichiometry is vital in industrial processes to optimize reactant use, minimize waste, and maximize product yield. It is used in chemical manufacturing, pharmaceuticals, and material science to ensure efficient and cost-effective production. Environmental applications. Stoichiometry is used in environmental chemistry to calculate pollutant concentrations, determine the required reagents for water treatment, and predict the outcomes of chemical reactions in ecosystems. Healthcare and pharmaceuticals. In healthcare, stoichiometry helps calculate medication dosages, design drug formulations, and analyze metabolic pathways. Accurate stoichiometric calculations ensure the safety and efficacy of pharmaceutical products.